Inscribed constructions. Number 2, construct a square inscribed in a circle. As you can see, we're given a circle. We're going to construct square ABCD inscribed in circle O. So step 1, we're going to mark a point A anywhere on the circle. Using a straight edge, we draw a diameter AC. So because the diameter goes through center O, we can just continue the segment going from A to O, and then we can mark and form point C. In step 2, we construct a perpendicular bisector of AC through the center of circle O. So basically what that means is we're going to start at point A, we go more than halfway, and then what's going to happen, we draw an arc that goes past point O. And then we maintain our distance. We start at point C, and then we're going to draw another arc that's going to be congruent to the first arc past point O. So what happens is we're going to form this arc first, and we maintain our compass width, and we're going to form this second arc. So in other words, the distance from A to this point and the distance from C to this point is going to be equal. Step 3, we're going to label the points where it intersects the circle as points B and D. And here's point B, and then here's point D. And once we've done that, we'll use a straight edge, and we're going to draw A to B, B to C, C to D, and then D to A. And then we just form square ABCD inscribed in circle O. So in part B, what's going to happen is we're going to trace over the dotted parts of the construction, and we're going to use a straight edge to form square ABCD inscribed in circle O. Then we're going to complete the statements that follow using the item bank. So basically what happens is we get our straight edge and we form diameter AC. And that's going to be true for each one of these circles. We're going to form diameter AC. So then from point A, what happens is we go a little bit past O with our compass, and what we're going to do is we're going to form this arc. And then we keep this distance, and we go to point C, and we get your compass, and then we form this arc. And then basically what happens is when we draw a perpendicular bisector, we're going to form points B and D. So notice the diagonals of a square are going to be congruent and perpendicular to each other. And then what happens, we just get our ruler and we start connecting. So this would be A to B. Right here will be B to C. This would be C to D. And then this would be D to A. And we just formed our square inscribed in the circle. So starting from point A again in the second one, what happens is we're going to go a little bit past O, and we're going to form this arc with our compass. And then from point C, you do the same thing with the compass here. You're going to form this arc. And then what happens is we form our intersection point of the diagonals. And then basically what happens now, we connect A to B. Okay, so we go A to B, and then we go B to C. Then we're going to go C to D. And then finally D to A. And then we just formed our square inscribed in a circle. Very similarly, this last one here, we start at point A, we go a little bit past O, and we form this arc. maintain this distance. Start at point C, and we're going to draw another arc just like this. Two intersection points. So what happens is we're going to have intersecting diagonals. And these diagonals are both congruent and perpendicular. So we're going to connect A to B. And then we connect B to C. And we connect C to D. And then followed by D to A. So in each of these cases, we have an inscribed square in a circle, and this construction is going to involve the intersection of two circles. Okay, and each of these circles are congruent. They have the same radius, but they have different centers. So, for example, if we start at point A, notice it's part of this circle here. And if we start at point C, it's part of this circle here. They have the same radius, but they have different centers. In each of these cases, if we look at triangle AOB, triangle BOC, triangle COD, triangle DOA, each of these triangles are four congruent isosceles right triangles. They're isosceles because these radii are congruent. They're right because this is a right angle here. They fit inside the square. Each of these triangles, they have a vertex angle. And that vertex angle is going to measure 90 degrees. And they have base angles. And each of them is going to measure 45 degrees. So each of these measures right here is 45 degrees. So we have an isosceles triangle, and they're right triangles, and they have a vertex angle that measures to 90 degrees, and they have base angles that measure to 45. Part C. For each of these constructions, if we look at angle ABC, okay, here's angle ABC. If we look at angle BCD, angle CDA, and angle DAB, each of these are inscribed angles. And these inscribed angles equal to 90 degrees. And if you look at angles AOB, angle BOC, if we look at angle COD, and then angle DOA, each of these angles are central angles, and they're each going to equal to 90 degrees.